right. Hi, everyone. Thanks again for joining us. My name is Jenna. I am a Built Environment Initiatives Coordinator with the Community Energy Association. Today, we're here with Ecolighten Energy Solutions, and we're going to be looking at best practices for retrofitting manufactured homes. So we'll get started right away so we can take advantage of the full 90 minutes together. Just advance the slide there, please, Ryan. All right, so the Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous people. Through our commitment to truth and reconciliation, we support First Nation, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd just like to begin our session today by acknowledging the Indigenous people from all of the diverse and beautiful places we are joining from. So I'm joining from what is now called Nelson, but for thousands of years has been the traditional homeland of the Snacks Nation, the Silks Nation, and the Tanaha Nation, and is home to the Métis and many diverse Indigenous peoples. So I'd just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do. So as part of my commitment to truth and reconciliation, I'm educating myself about the history of colonization and the cultures that were lost. So I just like to take this opportunity to challenge you to embark on your own journey with truth and reconciliation. I know we're all at different stages in this journey, but this challenge is inspired by a speech delivered by Jason Eagle Speaker as part of the IRCC citizenship ceremony. So it's a challenge to learn what you can. Research the unceded Indigenous territories that you build, live, work, and play on, seek out authentically Indigenous books, publications, and websites, and educate yourself about the treatment of First Nations in residential schools, the 60 scoop, undrinkable water on the reserves, broken treaties, and the thousands of murdered and missing Indigenous women, and the 94 calls of action from the Truth and Reconciliation Commission. So I've started my journey with a book written by Bob Joseph called 21 Things You May Not Know About the Indian Act. It's an eye-opening book that may help you on your journey. All right, perfect, thank you. So who are we? Community Energy Association, or CEA. We are a registered charity and nonprofit committed to accelerating bold action by local government and Indigenous communities related to climate and energy. So we have an unwavering commitment to our clients to provide services and support on the journey from awareness to plans and through to implementation. So we have 49 staff located across 28 communities throughout 5 provinces and territories. We bring our collective expertise, experiences, and commitment to truth and reconciliation and passion to reduce local greenhouse gas emissions while maximizing co-benefit so that communities are healthy and resilient. So what does that have to do with offering workshops around high performance building? Well, in BC, buildings are the 3rd highest emitters of greenhouse gas emissions. So for us, building better is climate action while providing opportunity to promote healthier and more comfortable homes in BC. So through the Kootenay Clean Energy Transition, or KSET, this is a project that was developed to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KSET, we want to help Kootenay and boundary communities prepare for a more energy efficient and healthy future through training and capacity building sessions like this one. So thanks to the generous support of the organizations you see listed at the bottom of the slide there, we're offering this free workshop as part of that education piece. And to see the full list of upcoming workshops and webinars, as well as past recordings of webinars, you can visit our website there at communityenergy.ca/built environment. You'll also see an opportunity to sign up for our high performance building newsletter that comes out every 2 months, just highlighting news and events around new builds and retrofits in BC. All right, and then one last plug here for those of you on this call who are doing retrofits. So I just wanted to introduce the Home Performance Contractors Network. So if you're doing heat pump installs, window and door retrofits, or installation upgrades, and your clients are wanting to access provincial and utility rebates, so this is the network to join. So becoming a member involves industry-specific training, and then upon completion of the training, you can receive training subsidies and costs back for the courses. Recently, HPSC partnered with TECA and BCIT to offer a micro-credential for a residential air-to-air heat pump specialist. So if you have any questions about this network or the micro-credential, feel free to reach out to Brady Sturgeon. So you'll see her email there on the slide. All right, and just a few webinar guidelines here for you folks to review. I'm just going to go over some housekeeping items before I pass things over to Ecolighten Energy Solutions. So to summarize, this slide is just really important that everybody here is respectful on the call, respectful of each other, respectful of our speakers. We do really want to foster a open and welcome environment for all of your questions. So please feel free to ask your questions throughout. Eduardo, I see your hand up there. I'll just finish these points here and we'll get to you there. So folks, you'll notice when signing in today that this session has been recorded. We'll be sharing it with everybody on this call along with the presentation slides, and we'll be posting it to our built environment webpage for public use. If you have questions as we go through the webinar, please raise your hand and we'll ask you to unmute yourself. We're also designating time at the end of the webinar for questions, so you can pop them in the chat and we can address them after the webinar. And I believe that's it. Before I introduce Ecolighten Energy Solutions and pass things over, Eduardo, do you want to ask your question there?
Well, yes, I have tried to figure out, because my company is dedicated to deep net zero energy retrofits, to become a member of the contractors network. And there's not such a thing as a net, that portion of that. There's no net zero energy contractors in that organization, or the possibility to actually sign up for it.
Okay, perfect. Yeah, they do. They have an HVAC stream, windows and doors stream,
general renovators,
and insulation
too.
stream, and general renovators. Yeah. So
that
Eduardo,
sounds like it'd be the best fit.
No, there is no. There on the screen when you go and try to sign up, it says that the retrofits part of the contractors is coming. Okay, I have contacted them and they say there's no fit for my company in their organization because they don't have the courses to teach people how to do deep net zero and retrofit. They only have windows, they have HVAC and then insulation, but nothing, nobody doing the
so they are working on their general retrofitter stream, and it will be coming out sooner than later. So Eduardo, we do have, I have your email address from your registration. Why don't I connect you with HPSC directly, and we'll send you some more information about that stream.
Don't you think that I have contacted them already? Is the fact is that things don't happen when they're needed. They happen when it is convenient, and that's the problem, I think.
Okay.
And
yeah.
There's a need for deep net zero and retrofit contractors, and they don't exist.
Yeah, totally understand, Eduardo. There is a sector council specific to general renovators within the HPSC. Like Jenna said, we can get Jovan or Tanya from the HPSC to let you know exactly what the timeline is for bringing in the or extending out the home performance contractor network to have the general renovator component in it.
Okay, please let them know to contact me. Thank you.
Thank you.
It's great to hear your interest.
All right, folks. So it's with great pleasure that I introduce Ryan Coleman there and Haziq Arif. So Ryan and Coleman, Ryan's the co-founder and Haziq is the project manager at Ecolighten Energy Solutions. So Ecolighten is an energy services consulting and home performance design company that supports utilities, government, builders, architects, and homeowners with practical, innovative solutions to improve energy efficiency and reduce greenhouse gas emissions in homes. So Ecolighten has broad knowledge in building science, house as a system, and mechanical HVAC design with expertise in technical research to quality assurance to energy efficiency program design, mobilization, and management. So the presentation today is based on Ecolighten's experience supporting the BC Hydro and Fortis BC with energy retrofits in manufactured homes across BC. So with great pleasure, I'll pass things along to you.
Thank you, Jenna. And for those who were thinking they were going to get Rob again this morning, we're sorry to disappoint. Haziq and I will do our best to shepherd you through. Today's presentation, as Jenna was saying, was on retrofitting of manufactured homes. So this is very much a niche market, as you'll soon find out. We've been supporting primarily the utilities with energy retrofits in this archetype. So our intention today is to kind of give you a bit of background on the market itself and these types of homes, as well as the opportunities to do energy retrofits, and then specifically walk you through examples of project work that's happening on the ground and the upgrades that are being done to improve the overall energy performance and comfort in the house. So Haziq and I are actually going to tag team this, so you're gonna hear from both of us throughout the presentation. So as I was saying, in terms of the agenda, we're going to provide just a bit of background on manufactured homes, talk through the types of upgrades that you find with this archetype, then give an overview of what the experience with retrofitting programs has been, and that's probably primarily through the lens of utility programs to date. And then we've done over 500 homes now, so there's lots of key learning that we wanted to share with folks. And as Jenna mentioned, we're happy to take questions through the presentation. So if you want to put it in the chat or raise your hand, feel free to ask. So just for a bit of context setting, so what is a mobile home or a manufactured home? Those are somewhat used interchangeably by folks. The actual industry itself has moved away from the term mobile as an identifier for manufactured homes, and all manufacturers, suppliers, and associations within that stakeholder group are using the term manufactured home. And there's a definition of their on the slide of how that is of how that is described. It's important to keep in context that it's not the same as a modular home. So modular home is often factory built, system built, or prefab, which is short for prefabricated home. Maybe I should do that so you can see the full pictures. The types of manufactured homes. So there's really two types of manufactured homes that you find in the market. On the left side, there is a single wide home. They're usually around sort of 700 to 900 square feet. And then you get double wide configurations as well, which creates a little bit more floor space. But almost at least in the ones that I've seen, and I've seen hundreds of these, 80 to 90% of them have additions, and these are additions that have been built after the manufactured home is brought to site, and that may be for additional storage, it may be for additional living space, it may be an office, it may just be an entryway. So they're all sort of like part manufactured and then part built with additions, and similar to single family detached homes or townhomes, any existing home, these are really each individual snowflakes. They have different configurations, different sizes, different types of additions, and other things. So there's a lot of nuance when it comes to getting into doing work on manufactured homes, as we will share with you. Just for some added context in terms of the market. So there is a manufactured home registry that is kept at the provincial level, and there's approximately 84,000 of these homes that are the registered ones that are in BC. 80% of them approximately are natural gas. There's a bit of it's not exactly 80-20 in terms of natural gas and electric. There is still some like oil-based homes and things like that. But for the most part, the majority are natural gas and electric, and the electric ones being primarily some in the interior, but mostly on Vancouver Island. The homes themselves, in terms of their location, they're typically located in either manufactured home parks or in independent private locations. So in the parks, the parks typically own the land, they own the home, and then obviously you have a separate setup for those that are outside of the parks. The Park Owners Alliance of British Columbia, that is the nonprofit association that represents the park owners, and there's 360 manufactured home community members, and that covers 60,000 households. So you can see a majority of the homes are actually located in parks. In terms of the performance issues with manufactured homes, so without question, these homes typically come with significant performance issues related to energy efficiency, occupant comfort, as well as health and safety. So they're very under-insulated. They have really poor envelopes. We see a lot of moisture issues with the house, so poor ventilation and just poor strategies around moisture management. Inefficient space heating and cooling systems. The ductwork or the distribution systems, if there's forced air systems, are typically inadequate and sometimes have issues with collapsed ductwork or disconnected ductwork, as you'll see with some photos, and they have significant air leakage. One of the reasons for this is and the houses that we're working, typically they've not been manufactured to an energy code. And when they're manufactured, they're not identified for where they may like be located. So you may have a house that's manufactured, you know, anywhere in North America, and it ends up in Prince George. And so there's disruption that can happen with transportation, and then it's also not set up maybe for the conditions of that climate zone. So it's kind of part of like just the recipe of actually manufacturing these things. And then the second piece is like some of the disruption that happens with the transportation, especially with the distribution systems. But overall, there's lots of opportunity to improve the performance of these homes. So as I was saying, here's a few examples for you. So up here on the top left, you can see this is the inside of the ductwork in the manufactured home. This is completely collapsed ductwork that needed to be remediated. We've got holes in the ductwork here where obviously the airflow that's going through this ductwork is not going to reach its intended location. It's going to fall out at the nearest spot, typically under the envelope too, which Haziq will talk about shortly. We've got a boot here and a register area inside the home. You can see some disconnecting here that doesn't allow for airflow. Here's some penetrations out to the exterior that are not sealed. These are a bit of some of the extreme cases here where you've got insulation that's completely fallen out. We re-insulated that, and you'll see a picture here momentarily. Here again is some of the, you get a shot here of the underbelly. So it's very small space that you're working in as well here. And this is the underbelly, and then the floor inside the house, and you've got insulation disconnected and missing in the home. So there's a so to address these issues, there's a portfolio of energy conservation measures that can be done. Typically, it requires both some enabling work, so be that health and safety related or minor home repairs, which we'll talk about, that need to be done to help facilitate the actual energy upgrades to improve the performance of the houses. That may be air sealing, maybe road barrier repair, underbelly insulation. Duct sealing is another common one, as you saw, like cutting into the road barrier and repairing disconnected or collapsed ductwork, or repairing or sealing of the ducting into the boots so that it's not blowing into the underbelly and depressurizing the house and providing poor performance. As well as ventilation. So dealing with moisture management and improving the indoor air quality with having better exhaust continuous ventilation. And then we've also are doing mechanical system replacements. So we're going to talk a little bit about furnace replacements as well as ductless heat pumps. We have a whole session, I think later this month or next month, Jenna, the next one, I believe, is on ductless heat pump retrofits for manufacturers' homes. So we'll dive deeper at that one, but we're doing quite a bit of work on retrofitting folks with electric resistance heating, be it baseboards, space heaters even, and electric furnaces, and moving those over to ductless or some ducted heat pumps when the ducting, it can has capacity to manage the airflows from a centrally ducted system. And then minor home repairs, so doing things like moisture barrier, dryer vent insulation, and other items, water line insulation, and some other items to also improve things. So just before I think I'll turn it over to Haziq here in a second. Yeah. Just in terms of the experience, so the primary retrofitting experience in British Columbia is really down to the Energy Conservation Assistance Program. So that's an affordable housing income qualifying program that's been around for almost 2 decades from BC Hydro and Fortis BC. So we started to move into this space in 2018, and work started initially with pilots, because we the projects that we do are fully funded by the utilities. So there is more extensive procedures, policies, as well as standard of work specifications to help manage the contractors and the upgrade projects that are happening on homes. So there's a lot of development work that goes into doing a program like this. As I mentioned, to date, we've done over 500 homes, and that includes all regions and virtually all climate zones. So Lower Mainland, Vancouver Island, as well as the northern and southern interiors. The process for participating in ECAP is, this is a simplified sort of sequencing, but folks make an application for eligibility, and then they get approval from the utilities, and then there's a series of site evaluations that can be up to like 3, with different folks coming in to look at and evaluate the home, as well as install some basic measures and do measure up and site visits for determining what the appropriate recipe is for doing the upgrades against the program policies and specifications. And then the installation itself, it can be 1 day, it can be 3 or 4 days, depending on the suite of measures that we're doing. If we're doing a whole retrofit with underbelly insulation, duct repair, duct sealing, ventilation, furnace upgrade, as well as other things, that can be up to 3 days of work. And then the last piece is actually quality assurance. So these houses get a either virtual or in-home evaluation to review the installation of the measures against the standard of work specifications of the program. So this is, and then I'll hand it over to Haziq to talk a little bit more about the specific measures themselves. So this gives you a little bit more granular example of the work that's happening. So this first shot over here on the left. So this is a gentleman who's under the in the crawl space, for lack of a better term, cutting into the road barrier, probably to do some duct sealing or duct repair work, or maybe creating some access for some underbelly or road barrier repair. But you can see the confined space that they're working in. This is stitching up and doing a road barrier repair. This is some of the after filling the belly with insulation, which Haziq will talk about here momentarily. You can see some of the duct sealing that's happened here with mastic. We have some other examples that show with tape. Here's some air sealing detailing. And then this is the after shot where the one that I showed you previously with all that fallen bad insulation and that was in disrepair. That was all remediated, and rock wool insulation was fixed to the underbelly to improve the thermal performance of the envelope. So before I turn it over to Haziq, maybe I'll pause there. I saw questions or comments or things that may have been popping up. Is there any things you need to address now, Jenna?
We did have a question that you could address quickly. Well, this will be addressed next week, but maybe just to...
Sure.
Dave just had a question about how often the electrical capacity in the park is a barrier to switching to ductless heat pumps.
Yeah, we have that question. Well, I'll save the detail on that for the next session. We do have that question come up from park owners in terms of like if all of these houses get retrofitted, like is it going to trigger a service upgrade for the park itself? And we do some evaluation of both the park kind of capacity, but the more specifically around the homes themselves. Like, do they have adequate service, and then do they have adequate panel as well as circuit availability to do heat pumps? And keep in mind, we are the ones that we're doing right now, we're taking these off of like a lot of amperage from electric furnaces and baseboard plug-in heaters all over the house, and baseboard heaters, and trying to put in a more efficient technology. But we'll get into the weeds on that. So you can join us at the end of June, whoever asked that question.
Perfect. And I did put the link in the chat there.
Perfect.
So you should see it. And then
Eduardo, you have a question?
Yes, the question is, do you have a range or an average cost for a retrofit of any of those 500 homes that you have done? Some kind of total cost of ownership that we can use as a reference, or the idea of how much would it cost?
Like an average cost to the house?
Maybe not an average, because every case is different.
Yeah, we
a range between
yeah.
low and high and something in between.
Yeah, we don't manage that data, Eduardo. That's managed at the utility level because they're funding the measures themselves. So we don't have information to present on that.
Okay, thank you.
No problem.
Yeah, I think we're good to move on. We have a couple questions in the chat about the IT program, but
Okay.
Lori, I'll answer you directly in the chat there.
All right, Haziq, you okay to take the baton.
Sounds good.
Perfect.
Thanks for that overview, Ryan. So, always interesting to talk about manufactured homes. Now, let's get into some of the actual measures that can be done in these specific housing types. So, let's start off with air sealing. So, now what is the objective? So, you'll see that all of our slides kind of have this format here where we talk about what is the objective of the measure and then what is the methodology to achieve that, and also some of the limitations, specifically ones that are maybe specific to manufactured homes. And then we've got some visuals too with each of the measures. So starting off with air sealing, so the objective is to seal the leakage areas in the home and also perform testing, typically with a blower door, to quantify the air leakage reductions in the home as well. Now, how do we achieve that? So the methodology is that first of all, the air leakage areas are identified in the home. And we found through the number of homes that we've done that some common leakage areas are around the hot water tank, as well as the tub, and penetrations under the sink, as well as other locations where renovations may have been performed in the past. And that's a pretty interesting one as well, because sometimes you step into a home that's 1970s kind of thing, but it's been renovated recently, top to bottom. So it looks quite good actually. But once you start to look underneath the home, you start to see that there's quite a lot of renovations and things, and the belly's falling apart where folks have cut into it and that kind of thing. So that's something to keep in mind. Now, for smaller leakage areas, typically we just use spray foam. So if you look on the right there, the bottom right, there's a little image there of the spray foam that is used. And then for larger holes though, so you can't just use spray foam sometimes. You might have to use some blocking, and then as well, just caulk that or use spray foam to seal that blocking as well. Now,
Oh,
sorry,
sorry.
so that was the methodology. Now the limitations are, and a lot of these do have to do with the belly cavity and the way the home is set up, that there is a lack of visibility in the belly cavity. So things that you can't, if the belly cavity looks good and you can't see those leakage from inside the home, it can be a little bit difficult to figure that out. So a tool that can be helpful there for folks is to use thermal cameras, specifically with blower door assisted investigation. So when you've got your blower door running, that can make it easier with a thermal camera to be able to see some of those uncommon leakage areas. Okay, next slide, please. Right, so now on this side, we've got some visuals here. And this is pretty interesting as well because it kind of shows the evolution of the program and the measures that we do. So you can see here on the left that the road barrier, the white, was actually replaced, and sort of similarly to the photo on the right there, the black road barrier section that was missing was replaced with a white kind of Tyvek home wrap. Now, that's how we started the program, but since then, since it's a better product, we've actually looked to source actual road barrier repair material and use that instead of the Tyvek there. And on just in the center there is a photo of a plumbing penetration, which is a bit of a smaller hole. I just use a little bit of duct tape to seal that up. Okay, now getting into ventilation. So the objective of this measure is to just provide better ventilation to homes that have poor existing ventilation. And it allows for continuous ventilation that is suitable and set for the entire home's requirements and reduces the risk of moisture issues, especially when we're installing insulation and air sealing. So we're tightening and insulating the home. So if it's the existing ventilation is poor, we want to be able to put proper ventilation there. Now the methodology there is that a continuously ventilating fan is installed in the bathroom ceiling typically, since that's the area that peak moisture. And this fan, like the Panasonic fan that you can see on the top right there, the way that that particular one works is that it has a low speed setting that it runs on all the time. And then there's a motion sensor in the center there. And based on occupancy of the washroom, and it will actually jump up to the high speed and then go back down to the lower. Now, limitations wise, so there is typically the attic space is not accessible, and there is quite a limited workspace there. And the roof is typically metal on these homes, which makes it a little bit difficult to get the flashings and the ceiling there. So sometimes we do have to look at alternative ventilation strategies, such as putting a fan through an exterior wall. And if it's not a sophisticated fan and it has a higher CFM, you may have to put that with a proper control strategy that automatically turns the fan on and off as required. And some of this is requirements of the program that we have to follow. So some folks may not have to follow these, but just, these are some of our learnings too that we're passing on to folks. And now one thing to keep in mind is that these homes are quite leaky compared to regular housing types. And therefore, there is quite a chance of overventilation if you're setting your fan too high there.
Before we go on, maybe Eduardo, did you have a question on this?
The question I have is about the amount of air that is this fan is extracting, but that air has to come from somewhere, comes from outside, and usually in the wintertime that's cold, very cold air. So that's you're fighting your heating system this way, in a very, very big way, because the amount of energy that is needed to keep that air coming from outside is huge. And usually these fans are working at, I don't know, maybe 40, maybe 30. How many cubic feet per minute are these guys taking out?
On the
10,
low
15,
setting,
20? Yeah,
on the low setting 30 typically.
30. So 30 is a huge amount of air. If you do the number, there's going to be a very, very big amount of energy that is literally just pumped out. Okay, so this kind of ventilation is going to work against the electricity or gas bill big time. And also another thing that is important is that it's bringing air from outside that is usually contaminated with PM 2.5 or PM 10. So that's another issue that this fan is going to affect the quality of air. And my other question is, do you have any way of controlling or measuring the CO2 content in the environment inside the home?
Was the last question a way of measuring the CO2 content?
CO2 content in the air inside the home, because obviously that is something that is being considered now a very difficult thing to control, and also a very big factor in the health of the people in the house.
Sure.
Yeah, good comment. So for the first one that you mentioned there with having to heat the air, so that is actually a good comment. So, and that's kind of what the last bullet is talking about, is that these homes are quite leaky, and in some cases, continuous ventilation is not the right option. So in this housing type in particular, in the program, whereas for other housing types, we do have continuous ventilation. For these ones, there is leniency there because they are quite a bit leakier than other housing types. So since they have so much passive ventilation, you can call it, having active ventilation may not be the best
Yeah.
option. And for CO2, we don't measure for CO2 in the program, but we do have carbon monoxide sort of detectors and things like that. And we do depressurization tests for safety purposes, but not air quality with CO2.
Yeah.
Well, CO2 causes a lot of problems that have not been addressed or detected before, but now they are, because it affects your mood, affects your ability to think, and all
Sure.
that stuff. If the level is about 1,000 parts per million in a period of 24 hours, is considered damaging the health of the people inside the house. Not monitoring now is a big mistake, because if you make the house very tight, the breathing of the people in the house will increase that level substantially. And I'm talking from experience, because I do control CO2 in the houses that I do, and it's a very, very big deal.
Yeah, it's good comment, Eduardo. We're at this point, we're not measuring that as part of like indoor air quality, so like we'll take that away though.
Okay, now getting
There
into
was,
minor.
Oh,
sorry,
another
there was a
comment?
question in the chat too, just how common or effective installation of decentralized HRBs are in this
Yeah,
home
we do.
type.
Yeah, we're not doing HRBs, and I've yet to see an HRB in a manufactured home.
We should probably preface at this point that the experience that we're relaying here is within
Yeah.
the context of the program. So there are specific limitations within the program as to what kind of things
Can be done.
can be done, can be funded, and that kind of thing. So some folks may want to look at HRBs, but in the program, we haven't done that.
Yeah. And also I would say keep in mind we're typically working in houses that are like year 2000 earlier, some 1970s manufactured homes. So they're very, very old, and in some states of disrepair.
Mhm.
Oh, and I guess, and I should just say the last thing is the program's philosophy is to leave the house in as good or better condition. So, and we'll talk about this in the key learnings. Like, is there other things that could be done, windows, etc., for sure, but it's outside the boundaries currently of the of the program. Go ahead, Haziq. Sorry.
Good comments. Okay, so let's talk about minor home repairs. So the objective of this measure is to perform ancillary measures to either facilitate other program measures or just ensure that the measures that we are installing do not have unintended consequences. So for example, air sealing, duct sealing, and belly cavity insulation and road barrier repair can cause the crawl space to be much colder due to the reduced leakage of heat and air into the crawl space. And for that, waterline insulation would be performed to reduce the risk of pipes freezing. That would be an option there. And now methodology and limitations. So some of the measures that we do here commonly are putting a moisture barrier when you've got a dirt floor. That's kind of the photo on the top right that you can see there. Also insulating water lines and replacing or insulating dry vents are common measures. So on the bottom right there and on the left photo here, you can see waterline insulation. In the middle is a moisture barrier, and on the right is a dry vent insulation. Now getting into underbelly, or what's referred to sometimes as belly cavity insulation. So the objective of this measure is to increase the insulation value inside that belly and improve the thermal performance of the building envelope. So the methodology is, now one thing that's important here is before insulation can be blown into the belly, we have to make sure that we seal up any large leakage areas, either at the floor connection or in the ductwork. Otherwise, when you blow insulation, you could risk blowing it into the house or into the ductwork. So we don't want that to happen. So that has to be sealed first. Once that is done, then you can typically holes are cut into the road barrier at regular intervals and insulation is blown, or so the blowing pipe is insulated and sort of moved in different locations and insulated in all directions. And once it's sort of packed tight with insulation, then the access holes as well as all unnecessary holes that are in the barrier are patched up. So you can see on the right there is what belly can be, sort of a typical condition that belly could be in. And then we'll look at what it looks like after the sealing here. So on the left, there's just some tuck tape there. So that's probably like since then for larger, I would say about a hole of that size, depending on what it look like under there. We typically want to actually use the road barrier repair material because that's quite a sizable repair area it looks like. So that's I guess these photos are kind of good because it shows about how we've kind of evolved in the program here. And on the very right, you can see there's an image of sort of access that is cut into the road barrier to be able to insert the blowing pipe. And the center is an interesting one. So that is rock wool insulation of an addition. So that is something that some additions are easier to access than others. Some is very difficult to work underneath, but the ones you can, oftentimes they're uninsulated. So being able to put that insulation is quite a benefit. Okay, I think next slide. If there are any questions or comments, feel free to just let me know as well.
Oh, somebody asked the insulation. Can you talk about the materials we use, Haziq?
Yeah, so when we're filling the belly, typically it's just blown in fiberglass. But for that addition, where we're putting bats down there, we put rock wool, typically done. Okay. Now let's talk about duct sealing. So the objective of this measure is to seal leakage areas in the ductwork, just to ensure that the warm, heated, pressurized air from the forced air furnace typically reaches inside the home and is able to reach all registers, even the further ones, and instead of just leaking out into the belly, which is outside the envelope of the home. So sort of the methodology and limitations here. So first of all, we do duct sealing from in the interior, that's from inside the home, just by using mastic and foil tape typically. And you can see a photo on the right there, bottom is unsealed and the top is when it has been sealed. Once that is done on all the registers, then a pressure pan test can be performed. That was something new to us, and we learned that down from the folks in Bellingham there that we'll talk about in a bit. So you do this in conjunction with a blower door, and you basically depressurize the home, and then you measure what is the pressure differential there. So ideally you want it to be at 0, but and closer to -50 because that's what we depressurize to. The closer that is to the outside of the home, and it signifies that there is significant leakage right at the measuring location, which should be fixed. And the way that would be done would be to do it from the exterior, which is the underneath. So that would have to be cut into the road barrier and then cut into the ductwork typically as well, and repaired with mastic and fiberglass mesh tape. Now, like anything else, when we're talking about the belly, there is limitations with being able to visibly view some ductwork disconnects and holes. Now, you can use mirrors and flashlights to be able to see in certain duct configurations. With other ones, like boot ones in particular, it's quite a bit harder to see with mirrors and things like that.
Eduardo, did you have a question?
Yes, the question is, I'm sure that you have heard of air sealing and ducts and houses using pressurized.
Using aeroseal,
wood.
yeah.
Yeah, so isn't it like a very interesting application for this because the work is minimized?
Yeah, we've looked at it. We haven't piloted it yet.
Okay.
Yeah, it's a consideration. There's also costs associated with it and things like that. So, but we have looked at it.
Yeah, it
We
is an
may trial
interesting
it.
one. Yeah, it is an interesting one because it can get those smaller holes in the ductwork, smaller leakage sealed up quite well. But one thing that we do run into as well is that sometimes there's quite significant disconnects and that kind
Yeah.
of thing. So
Yeah.
there will need to be that. This, I guess, a conjunction approach could be something.
It's a nice finishing product. But the stuff that we're dealing with, as I showed you earlier, in terms of like collapsed ductwork, as Haziq's highlighting there, like completely disconnected joints and things, like that's not an aeroseal solution. Like it needs repair.
So just looking at these photos here on the left, you can see another example, but this is now the boot kind of example there. And these are typically more difficult to be able to look into with flashlights and mirrors and kind of see the main trunk line because you can't typically see it a whole lot from there. In the center, you just got a photo of what the exterior duct sealing looks like. You typically got the installer lying on their back, cutting into the ductwork and reaching in there and repairing that. And on the right there is just a photo of sort of the paperwork and some pressure pan results that were taken out in the field.
That data is what's used, as Haziq was saying, is like that diagnostic testing, pressure pan testing is used to identify where the leakages areas are potentially underneath, and to sort of triangulate, as well as make decision on whether or not the duct sealing stops from the interior or we go to the exterior, which is obviously more evasive and time consuming and challenging.
Yeah, I should mention that is an important piece, especially for cutting into the road barrier when there isn't a hole already. Is it's kind of the good thing is you're able to fix the ductwork, but you have to cut into the road barrier. You have to pull out the insulation. You have to cut into the ductwork from underneath, typically, so that you can access the leakage part. So you have to do a lot once you're done sealing your repair. You have to do a lot of additional sealing and repair work to be able to finish up. So it's quite a time consuming. Each cut that you make and each repair that you make does take quite a bit of time. Okay, now let's talk about furnaces. So the objective is simply to replace a lower efficiency furnace like a standard or mid with a high efficiency model. And the way that that is done is, first of all, the BTU sizing requirement for the home is determined by load calculation and the appropriate furnace size is selected. Now, similar to belly cavity insulation, interestingly here as well, before the furnace goes in, the ductwork should be inspected and sealed prior to the furnace replacement, just because leakage is bad enough, but when you've actually got heated pressurized air kind of blowing directly out of there, that's orders of magnitude kind of worse for energy efficiency. So, and one interesting note as well. So if you look on the image there on the right, so that is not a manufactured home specific furnace. That is it is approved for manufactured homes, but it's not specifically made for the sizing of a manufactured home. So, and the reason in the program we did do those kind of furnaces, but what we ended up finding was that the regular residential furnaces have much better performance as well as reliability and durability than the manufactured home specific furnaces. And the downside, though, is that, and we can talk a bit more about kind of some specifics there, but for now, let's leave it there. But the downside with these regular residential furnaces is that they are larger in dimension. So either they will protrude into the hallway, or if there's space behind to cut into that wall, then they can be offset, but then that requires specialized fittings and things like that as well. So it is a bit of a trickier installation, but it is once it's done, it is a good finished product. Oftentimes much better, at least in our opinion, than the regular residential
Yeah.
furnaces.
I mean, we have prescriptive requirements around filtration. So as you can see here, there's a 4-inch filter box, and that is something that we mandate, I guess, in the program to improve screening of particulates and just indoor air quality for houses. So we had to get creative and learn from installations to be able to come up with the recipe for doing these type of installs in manufactured homes, as well as educating Technical Safety BC and others on using regular residential furnaces in manufactured home applications. Because quite frankly, we trialed out some of the manufactured home brand furnaces that I'll keep nameless since we're recording this, but they were very poor performance in terms of product failure. And the service behind the furnace is when contacting the manufacturers was absent. So based on the amount of calls we were getting and the issues that we were seeing, which were engineering and manufacturing issues at scale, we decided that it was best that we limit our liability associated with that and move to a more robust, resilient piece of equipment.
Yeah, and folks that are familiar with the manufactured home furnaces will probably realize the kind of filtration and the way that it is, like the 1-inch filters that they have, the horsehair filters typically, and how much of an improvement getting a 4 or 5-inch filter with a prefabricated cabinet such as this would be. Now, let's look at these visuals here. So this is the same, I think it's the same job as the previous photo. This is just before the little drywall cover there in the front was installed. So you can see the furnace there, as well as the filtration and the 2-pipe termination from the inside. And from the very right photo is the termination on the outside of the home. And in the center is the commissioning sheet that the program uses, which basically records the data at the time of installation and makes sure that the static pressures and things are within range, which is an important one. And that's one of the other issues, is that the CFM delivery on those manufactured home specific furnaces is typically higher than this, and the ductwork is already undersized. So there's a real risk, there's a real issue with sort of noise and just static pressure being out of range. So when we're putting this furnace, one thing that was on the previous slide was that since there does need to be a fitting to be able to mate the furnace to the plenum there, but so that is a custom fitting, but if you're okay with the furnace protruding, that can be kind of mass produced. But the other benefit there as well is that also allows you space to be able to put a spill grill if needed, to be able to release some air over there for a better ESP number.
Good point.
Yeah, I think that's everything. So if folks have any questions on furnaces in the chat potentially before we move on.
No questions related to furnaces. If there's a couple questions there, we can save for the Q&A, Greg and Cameron.
Okay.
I see you.
Sounds good. Okay, so that was for gas situations. And then moving on to electric, the program has started putting in ductless heat pumps, particularly in homes that have electrical resistance heating. So what is the methodology here? So the home is first evaluated for electrical service/panel capacity, and the layout of the home itself is sort of analyzed, and determination is made on where the indoor and the outdoor units would be located, and the layout of the home sort of informs with the insulation values, the type of windows and things like that. That information goes into a TECA F280 load calculation to determine the heating and cooling requirements for the home. And based on the existing heating sources and things like that as well, it determines whether supplemental or full 100% backup heating would be required, and what in-house can serve as that. Once we have all that information, and this is a bit of an important one, I guess in terms of backup heating, is if you use cold climate heat pumps in the lower mainland and a lot of the Vancouver Island, you're probably not going to run into them ever shutting off. But an issue that you do have with heat pumps, which you don't have with things like furnaces, is that at below a certain temperature, the outdoor unit will turn off altogether, and that system will no longer operate. So when you start getting up north, that is something to keep in mind. And in those kind of cases, you want to make sure that you do have 100% backup heat, which is a lot simpler when it comes to ducted heat pumps. But for ductless, that is a consideration that needs to be carefully thought of, which we do in the program. Once all that is done, then the heat pump is simply installed as per the manufacturing program requirements. Not a whole lot, like we just do it to the standards. We do have some prescriptive requirements, but they are pretty plug and play. We just have certain
Quality
requirements.
attributes.
Yeah, exactly. Performance requirements that we do have, and consideration, for example, is given to noise levels as well as snow accumulation to determine whether a debris shelter would need to go in. And I think a lot of these outdoor units do have acoustic blankets kind of built in, so that is a good thing there as well. Now let's look at these photos. So the left photo just shows the refrigerant lines that are going into the sealed conduit there. The second photo is the indoor unit, and the last photo is the outdoor unit. So just the components of the heat pump there. Okay, maybe we can move on. So yeah, one comment I was just going to make. I think someone was referring to electrical considerations. So there are electrical considerations. Now, if you for other heat, like if you're putting a central heat pump in and you're taking an electric furnace, that is quite simple. Not a whole lot to like. I mean, you still got to check it, but that's most likely going to work out well. If you already have existing electrical heat in your home, then there may be a little bit of reconfiguration needed, but that's also something doable. It gets a little bit tricky if folks typically had an oil furnace or something like that to begin with, and they've since used portable heaters, and now we're looking to put a ductless heat pump. That's kind of one of the more trickier situations is when folks are using portable heaters as their primary heating source, and how do you put a ductless to service the home and make sure the supplemental and the backup requirements are met.
Haziq, you got some good teasers there for the late June webinar.
So hopefully that provides some context to that person who asked that question, and I guess we'll leave the more details for the next one here.
Sure.
Okay, now let's get into the key learnings. Was there another question?
I think there was a couple that came up there about heat pumps or something. Why don't we just save them to the end so we can get through the slides, and then we'll.
We're almost at the end here,
Yeah,
folks. So
we're getting close.
Yeah. So let's talk about the key learnings overall from working all these different measures over, evolving over years, is that manufactured homes are unique. And some folks wouldn't think so because they are built in a factory to a certain spec, it's CSA's at 240 standard. But over time, that has changed quite a bit. And the construction, the transportation, as well as the configuration on the site, especially when it comes to additions, can really change the layout of the home and basically the overall construction of the entire home. And that basically means that a one-size-fits-all approach is not possible typically for these housing types. And also enabling work is required oftentimes in the form of, for example, moisture barrier, duct repair, and that kind of thing to be able to get more advanced measures into the home to address performance issues. Now, key learning number 2 is specialized work. So this is a very specialized work, and there are contractor capacity to support these energy upgrades is typically more limited versus conventional single family or ground oriented townhomes. And there are little to no specialized contractors for these manufactured homes. And so the utility programs, for that reason, actually build capacity with investment and technical training from the subject matter experts. In this case, it was the Bellingham Building Performance Center. And also, they're typically not real manufactured home technical specs or standardized permitting inspection requirements to guide energy retrofits and quality workmanship for these housing types. So that's something that the program had to sort of work on and be able to come to kind of a standardized standard work spec for this kind of work here.
Yeah, I would just emphasize both of these points actually a little bit more. Part of the reason why we had to sort of like scale up the program is because this was all net new work. Like doing this type of like duct repair, blowing in insulation into an underbelly and understanding the repair that's needed, and the training, we really started from scratch to skill up the contractors who were working on the program on single family and townhomes, and trying to apply some of the philosophies and methodologies there, but like get them the specialized training that they needed to work on this. So Bellingham Building Performance Center, for folks who are interested in this type of work, I would direct you to check them out. There's a gentleman by the name of Chris Clay there, who is a subject matter expert in energy retrofits for manufactured homes, and this has been a core competency of theirs for decades now, and we're just sort of getting started in it. So they're an excellent technical resource. And then just on the last piece, there is no code, and many of these houses weren't built to the Z240 standard for CSA. So we don't know what we're walking into until we're walking into it, and sort of guiding the workmanship and things like that. And we've had to develop specifications based on information from US-based approaches, as well as our piloting and things like that, to give guidance to the contractors on what quality workmanship looks like, and how we're going to evaluate that as part of the quality assurance, and ensure that the savings are there, and it's delivering the objectives of comfort and energy performance and persistence and things.
Very good. And then sort of the key learning number 3 is scope limitations. So I think this kind of addresses and references some of the questions folks were asking, is that the utility programs are limited in the type of energy upgrades and the extent of the work that can be completed on manufactured homes. So for example, the program is not able to complete at times all the upgrades that are needed to address the home issues in all situations. For example, working in additions, maybe that is something that would be beneficial, but the program would not be able to facilitate that. And moisture problem, if it gets past a certain point, that is something that should be remediated, but due to the risk profile of the program, we wouldn't be able to work in that home past that point. And in HVAC and weatherization work is limited to the program's policies and specs. For example, program does not address windows or domestic hot water. And also that there are things like fuel switching limitations. So um, the participant may prefer a certain type of heating system, but if there's no savings, because the program does go off of energy savings, if there's no savings to justify that, then maybe that's not something that would be possible. Okay, and key learning number 4 is equipment sizing and selection. So the ECAP standard work specifications and the approach to high efficiency furnaces and ductless heat pumps did require additional technical updates and support. So the main issues that were encountered was issues with poor ductwork, which created challenges with high efficiency furnace sizing and selection to achieve optimized performance that we expect in other housing types in the program. And that's for furnaces. And when it comes to heat pumps, participants in colder climates, which is climate zone 5 or greater, typically require greater BTU sizing and do need to consider supplementary or 100% backup heating with heat pumps, which is not something that, which is basically, that was something that was new to the program and we had to work through. Okay, continuing on. The next key learning was managing expectations. So the utility program did identify sensitivities in managing participant understanding of the extent of the work to be completed due to program limitations. Participants have expressed dissatisfaction with the program not upgrading certain aspects of the home, for example, additions, or changing attributes, for example, having a bathroom fan and controls with continuous ventilation. And escalated participants require increased resources and efforts from the program partners to resolve, and consents and waivers are created to help manage participant expectations in these cases.
Yeah, again, just to reemphasize, the work that we're doing is fully funded by the utilities. That means it's both the enabling work as well as the stuff that's associated with the actual energy upgrades. So there are limitations on expenditure and cost benefit. So folks rightfully, they know we're in the house, they know we're doing a bunch of work, and they're like, well, what about this, what about that? And so you have to be sensitive to just understanding their needs and look and their requests for doing more elaborate work. Okay, do you want to do this one, Haziq, or do you want me to do it?
Sure. Oh, well, yeah, I'll just keep going.
Okay.
Okay, so let's summarize everything we spoke about there. So, kind of bringing it back out of individual measures and just overall back into the housing type. So, number one, manufactured homes typically underperform in terms of energy efficiency and comfort. And this is an inherent issue resulting from their overall design and construction, as well as just the way they're transported onto site and what happens along the way and then once they're put on site and things like that. And just as time goes on, the durability compared to other housing types. Now, these are manufactured homes are a unique archetype for energy retrofits, and they require customized solutions to address their performance issues. There is limited skilled contractor capacity that are specialized in providing weatherization and HVAC upgrades for manufactured homes. And the utility programs provide an industry reference of some of the challenges as well as opportunities with energy retrofits for this particular market segment. So hopefully that was a bit of overview and sort of help folks out to get an understanding of what we see in the field. And I'll pass it on to you, Ryan, if you want to make any final comments.
No, I think there were some questions. So
Yeah. So just
Thanks,
before
Jenna.
we move on into the Q&A, thanks you both for a great presentation. And thanks to everyone who participated with your questions. We will have an opportunity here shortly for a Q&A portion. So the first question I have up on here. So this, I think Greg posed this question hoping that there was going to be someone else on the call who had some input, but maybe just to you two as well. Greg's just wondering if anyone's done a cost analysis regarding air loss with or without an aeroseal system within existing ducts that are not accessible.
I am not aware of anything that's published on that. I don't know. I'm sure they may have some information on that as well as, and maybe they've done some independent stuff, but I've not just seen a straight cost analysis on that system.
Yeah, not on the air seal particularly, but I will just mention that from the duct sealing efforts that we do in the program, we do actually get pretty significant reductions just without air seal, just from the other installation measures. And I'm not sure how if there's a good way to quantify because it's not the same as regular leakage in a home since you've actually completed air going through there. But I think the air seal I think it could get great reductions in terms of energy usage, but I haven't seen the data myself.
Yeah, our overall ELA reductions in terms of air tightness with the combination of the air sealing and the duct sealing, we typically get like twice as much in manufactured homes than we do in regular single family townhomes.
Great, thank you. And yeah, if anyone else is aware kind of any cost analysis that you've seen, feel free to share that in the chat. Perfect. And then Cameron asks, is the road barrier seen as an airtight membrane? Seems like this would have an impact on the impact and effectiveness of duct sealing if all ducting is contained within the road barrier.
Great question.
So there are different types of road barriers, but the most common one and the ones I think that we saw in the presentation here were the black flexible one. So that isn't considered a membrane, and it's actually not part of the building. It's not supposed to be part of the building envelope at all, actually. So the name is a road barrier, and really it's supposed to be for when you're transporting it down the road to be able to hold the insulation in place and that kind of thing. So the real air sealing plane would be the underfloor rather than the road barrier. But I will say that from some of the road barrier repair work that we have done, especially in pilots, where we do blower door tests after basically anything that we do, we have gotten reductions from doing that with sealing up the road barrier, but it's not typically the place you'd want to focus to get your reductions. Hopefully that answers the question.
Yeah, absolutely. Thank you so much. So not meant to be part of that building envelope, but kind of is by default anyway. So opportunities to improve your air loss by air sealing there too.
Really good question.
Thanks, Cameron.
Can I ask a real quick follow-up on that?
Yeah.
Go ahead.
Just as a broader approach, and this probably is out of scope for some of the work, is conversion to a crawl space ever something that is considered, especially when you're trying to tie together all of the additions or planning additions or anything like that?
Cameron, another good question. We just had this conversation last week. Go ahead, Haziq.
Yeah, we're just discussing different methodologies because, like we discussed on the call, having the visibility issue and a road barrier, we're just discussing alternative and in the code for other housing types, we're moving away from vented crawl spaces to conditioned crawl spaces. So is there something similar that could happen for manufactured homes that would allow that entire space to be opened up and visible to be able to be sealed, the ductwork and things properly, and that kind of thing? And it would make it a lot simpler. Yeah, exactly like your comment, Cameron. So that's something we're looking at. But we're also trying to find industry precedents for that work being done. So if anyone on the call here does do that work or has, knows of people who do that work, and it'd be good to get that information. So that's one of the things we're looking at. Great question.
Great, thank you. We do have a couple of heat pump questions. I know we're covering this in a month, but folks
Everybody loves heat pumps.
Can't help themselves. Yeah. All right. So Dave says, he asks, why is backup heat source required? Would it be required if a cold weather heat pump is installed?
Good question. So even with a cold weather heat pump, depending on the location, and we go off of the heating, like the design temperature, the 2.5%, the 1%, even if you wanna be a little bit safer. But the reality is that what we're experiencing now in the winter times is there are days where the cold snaps go below that. And when you have a heating system that shuts off below that temperature, and especially in a manufactured home where you've got greater leakage and less insulation, you can have pipes freezing and things like that. So therefore, we would want to have a backup heat source, which may not be required in the lower mainland, by the way. So if what you're doing is all based in the lower mainland, it may not be an issue for you. But other regions, yes, it could be.
We'll share this later this month, but we've got like a working decision-making hierarchy that walks through like the climate zones as to like from going from no backup to supplementary to 100% backup, and kind of like how you make decisions on that in terms of sizing and selection and what might be there, what might not be there, capacity on panels, all that kind of stuff. Anyways, we'll dig into that in later June.
A little teaser. Great. And yeah, folks on the call, if the date of the June webinar doesn't work for you, register anyway, because we do send out a recording link and the presentation slides to all who registered. So yeah, if you want to learn more about heat pumps, we do have one more heat pump question. Cameron just asks, are ducted air source heat pumps not a viable option for replacement of homes with an existing furnace?
Is that referring to replacing the existing furnace?
Yeah, like maybe talk about what we're trying to do with electric furnaces now, Haziq.
Yeah. So when you've got an electric furnace, the much better option is to go ahead and do a ducted air source heat pump, and that's really good too because of the backup heating that we mentioned. Now, obviously, when you are using the ductwork, you do have to make sure the ductwork is sealed up and is in good condition. But the good thing with the ducted heat pumps is that you can have backup heat in the same system that is controlled by the same controls. So it makes it very simple for participants. You don't have to the system makes all the decisions for you. When even if your heat pump outside was to shut off and you have sufficient 100% backup heat from electric, there's going to be no interruption to the heat in the home. So that is a much more sophisticated system, and it is a good option that the program is piloting as well.
Yeah, and so we've been reluctant to go there with older homes because of the state of the ductwork and heat pumps running at such higher CFMs. And so where we ventured into is if we're confident in the ductwork condition the age of the home, and then if it actually has central AC already, like we've had one that actually did, then we felt good about the opportunity to pilot ducted systems into the it's the optimal solution. We just need to make sure we're not having unintended consequences. So we're finding our way through that when it comes to manufactured homes. But the objective would be for electric furnaces, we're putting in centrally ducted heat pumps, but there's nuance.
Awesome, thanks for that. And the static pressure issue was one of the questions that I'd heard raised before, and I was really wondering if the single versus double wide, where you have that central trunk versus the central trunk with branches, if that has any relation to the issue.
Yeah, we haven't done a double wide yet.
You can come by my place sometime, have a look.
Yeah, we have seen some double wides, not in the context of heat pumps and things, but where that what they call that crossover connection is in rough shape. So, you know, that's something to look into as well, is making sure that that is there, is so that you can have air transfer from one to the other, to both sides of the home. So yeah, but we haven't done a double wide.
Awesome, thanks.
Great, and Kirsten has another question around ductwork. She asks, do all manufactured homes get the ductwork sized in the factory with no considerations to the climate zone?
That's a great question for the manufacturers.
That is a really good question.
And that's a really good point. But like our point initially is that like the houses that we're working in, okay, like now I think they're like generally speaking, is there is and I'm not an expert in the Z240 standard, but which is the performance standard for these things being manufactured. There is better alignment in terms of like energy requirements now for them manufacturing them, but I don't know how that works in terms of the detail of like manufacturing this one specifically for cold climates and making sure that all the components are good for, you know, Prince George. Where the houses that we're working on were manufactured in the 1970s, the 1980s, right? Where people didn't even talk about this. And so they've ended up in Prince George, they've ended up in you know, in the Kootenays, or they've ended up in, yeah, they've ended up in places where they probably shouldn't have ended up in. And so we're trying to help folks out who have really poor performance because of the condition, the type of how it was manufactured, and just the state of it.
Right. Yeah. And like what I'm noticing was I'm a refrigeration contractor, and I'm getting a lot of customers saying, "Oh, I want air conditioning in my mobile home," and I've never done that, and I'm like, "Well, I'll have to look into it and see what it is." But then I'm thinking, like, if the ductwork's undersized already, like what you guys are saying,
It is.
then it's like, well, you're not going to put air conditioning in there, especially with a high efficiency furnace that already is more restrictive than a traditional furnace.
Yeah.
So,
and we actually got to the point of Kirsten, of with our furnaces of doing decibel stuff on in the house because we wanted to make sure that like people like recognize that there was noise here before, and this may get a little noisier because of the ductwork, because of folks complaining about noise and comfort and stuff. But that's why you got to do the diagnostics, right?
Right. I had a brand new manufactured home. I was just called in for a warranty issue. It's only been in 6 months. I had to redo the heat exchanger was leaking, and it was a whole huge job. I had to basically redo the whole manufacturer install. But they're complaining of noisy, the ductwork, and then they have the fresh air coming in to the blower assembly, no filter or anything. So their furnace after 6 months was just disgustingly dirty. And then I was thinking about when this started that their fresh air for their like HRV replacement kind of thing comes into the furnace there. And then they have their exhaust fan in the laundry room, which is where the furnace is. And you're saying put it in the bathroom. So they're just short cycling the air between the fresh air between the furnace coming in and the bathroom exhaust within 6 feet of it. And really, so it's like there's not even a regulation for that then with these mobile homes. Not really.
And from a design standpoint, I don't know. I'm not well versed enough to answer that one.
All right. Thanks.
Yeah, we're not too familiar with the HRVs, but the issues you're mentioning there with the furnaces, that those are the same ones that we run into.
Yeah.
Yeah. So that's interesting, actually, that the issues that we run in with retrofits would actually apply to new housing as well, with these new furnaces going.
But that's very sad to hear about you know, the filtration and, you know, on a new home. Like that's just crazy.
And
Unreal.
it's step 5, this one that I just did.
Wow.
According to them. They said 2 air changes an hour.
Wow. Sometimes,
Yeah, Lori,
sometimes what's on the surface is not what's underneath.
Lori just made a comment too. She bought a home with a huge exterior furnace and AC that has ducts running under the house connecting the built-in ducts.
Just bought a,
Bought a home,
oh,
so a manufactured home.
Hi,
Hi, Lori.
hi,
I
Lori.
bought I bought my manufactured home about 4 years ago, and it has a huge exterior furnace AC unit,
Okay.
and then the monster slinky ducts that go under the home on
Mhm.
either side of the, it's a double wide on either side,
Mhm.
connecting into the built-in ductwork. I have no idea. I'm warm when I turn it on, so I have no idea about efficiency or anything. But of course, the ducts are beside the water lines, so they're keeping them from freezing in the winter. If I went to a ductless system, the pipes would freeze. That's for June.
Yeah.
Discussion for June. So I do have a question before you guys leave. You mentioned that you are funded by something to go in and do these homes.
We're not funded. Like we're not doing the work.
I
We're
see.
contractors are doing the work. They're funded by the utilities to do the work in the houses. So the homeowners do not have a capital outlay to get the work done, but they need to meet certain qualifications in terms of eligibility.
Yeah, it is an income qualified program.
Oh, well, there is a cost. It's not totally funded. And you can't really find, as you say, you can't really find workers in your area
Yeah.
always.
Yeah.
So
That are specialized in this type of work.
yeah, it's limited and confusing, and nobody wants to go under houses. Manufactured homes are really challenged.
Oh, 100%. Like, well, that's why we showed you that picture of the crawl space. Like, you know, and I was talking to, you know, I mentioned Chris Clay from Bellingham Building Performance Center, and he was talking about, we've been pretty lucky with turnover and things like that, and in terms of the contractors, but they see a lot of attrition in terms of workers, because of the working environment. Like you're in a, you know, you're in a like a really small crawl space, and you're like cutting into like road barriers and insulation falling on you, and like trying to like fix ductwork, and it's snowing outside. Like it ain't an office.
Yeah, I can attest to that. It's brutal, especially the dirt ones. And
Yeah.
like in Kelowna, when I was there were so many black widows that I was like, this is a death trap, basically. Like there was one that I had to crawl into. It was like a 2-foot dirt crawl space, but it was really like 6 inches because they dug out a hole to the furnace. Black widows completely covering the entrance, completely covering everything. I'm taking a spoon in there, and I'm like, if I get bit by multiple, like there was hundreds in there, then like who's gonna call them in and crawl with me? And I'm like, I'm not getting paid enough for this. You know, so it's like, even with my company, we're basically drawing a policy that we don't want to work on trailers. We're like, screw it. If we have to go underneath the trailer, call another company, because we don't need the work that bad, because it's a terrible work environment.
Yeah.
Lots of challenges with retrofitting manufactured homes. Sorry, we do still
Yeah.
have another couple questions in the
Okay.
chat that I just want to
Sure.
address before our time's up here. Natasha just asks, she said, I know this is kind of beyond the scope of the work with the ECAP program, but is there any attention to embodied energy or carbon calculations of retrofit materials?
No, not, we're not doing that type of analysis yet on this. We're like I said, we're making these houses better, and like, and so that's the intent, is to try to just improve the energy performance. I'm sure at some point it'll evolve into those places and the material piece, but right now it's about trying to, it's about trying, as I said, Jen, I told you this, like, and I'll share this maybe in our webinar at the end of June. One of the first manufactured homes I walked into, it was a lady, she was 82 years old, and she had her oven door open when I walked into the house, and that was so that she could preheat her home. The next lady that I walked into her house, she had plug-in heaters and nothing in her back bedroom in the back of the trailer. And I asked her like how she stays warm, and she said, I have a big dog. I want people to keep in mind, like this is the types of conditions that we're trying to address, and just really we're trying to make healthier, more comfortable, and more energy efficient environments. So yeah, embodied carbon calculations, those kind of things, sure, we'll get there. But at this point, we're just trying to make people healthier and in a safer environment.
Yeah, great. Thanks for that. And that kind of relates to this next question then. I know that you did touch on this in the presentation. It's just around steps to control indoor air quality with these upgrades. Maybe any recommendations outside of the work that was done with ECAP?
Yeah, I mean, like we're big proponents of like ventilate, like proper bathroom fans and ventilation and filtration, like as you saw, like that's why we don't allow for thick 1-inch filters and rock catcher filters and things like that. We want to make sure that like when we put in this equipment, it's being supplemented with the right components and the right installation practices to get the longevity and the persistence of savings. And we do from a safety standpoint, if you ask any contractor out there how many of them are doing or actually know of the procedure to do a depressurization test in a house, it will be quite rare. We do depressurization tests in homes to make sure that there's we're minimizing the risk of carbon monoxide. And we also install carbon monoxide monitors. We have decision making around that. We have a big homeowner education component too around maintenance and safety. And yeah, anything else, Haziq? Am I missing anything there?
No, I think you covered everything. So that depressurization stuff and carbon monoxide, that's health and safety related more so. And for indoor air quality, there's bathroom fans like Ryan just mentioned, and when you got a furnace, the filtration. And I think that's about it. Like, so that we try to incorporate those in the measures of the program. But yeah, I think that's covering everything.
Great, thank you. And Jim, you have your hand up there.
Has anyone ever considered the possibility of installing a ridge vent on the roof, because the attic insulation and ventilation is woefully inadequate in most homes? I've done this on regular buildings, but not a mobile home, and I'm not sure how that would affect the structure of the truss and the bracing, et cetera. But a ridge vent definitely is excellent exit venting, and perhaps then some improvement could be made to the inlet venting for the attic area.
That is an interesting one. We haven't looked at it too much. When we were starting the program, we were considering trying to top up the insulation in the attic space, but because of the concern that you mentioned of the existing not having a whole lot of ventilation space to begin with, we were advised by the engineering firm that we were in contact with not to go down that route. So we haven't looked at getting more ventilation in the attic, specifically ridge venting. So good question, but not something we looked into.
Great. All right, and a last question. Lori asks, how can she get Ecolighten to advise her? So do you guys do one-on-one supports with homeowners?
Yeah, I mean, we like they can shoot us an email or a phone call. We had it up there on the slides. And if they're located in the Kootenays, like I guess retrofit assists, we can do some work with or in Whistler Squamish. We're supporting you guys with customer inquiries related to energy retrofits. But just give us a shout. We'll do our best to help you out.
Great, thanks. So yeah, Lori, you'll find the contact information on the final slide when we share those out. All right, well, that brings us to closing time. Thanks so much, Ryan and Haziq. Thanks to everyone who's joined us on this call. Thanks for your great questions. Really appreciate it. And yeah, join us again a month from now to to ask all the questions you have about heat pumps and in retrofitting manufactured homes.
See you then, Jenna. Thanks, everybody. Good
Thank you.
discussion. Bye now.